Today we're going to be talking about solving rational equations. So in particular, this is going to really resemble actually resolving complex rational expressions, and that the key is to multiply everybody by the least common denominator, and that's going to clear all the fractions so that you can just solve the equation. Once you've cleared all the fractions, it's going to feel a lot like just solving regular old-fashioned equations, but the key step that's going to feel a little bit different is checking for extraneous solutions. So aka you need to double check this with the domain of that original rational expression, which was something we touched on in the first video about rational expressions, but this will be kind of a more formal step on why we cared about that domain in the first place. So let's go ahead and just see this in action. So for example, with x plus 1 over x equals 3, the least common denominator between everybody is going to be x. So on both sides, I want to multiply by x. As long as I've multiplied both sides by x, I'm good. That's going to, x divided by x becomes 1, and then you're just left with x plus 1 equals 3x. I can then solve this by more traditional methods, where I would want to move all my x's to one side, and then divide by 2 to undo multiplying x by 2 to get that x is equal to 1/2. You want to make sure that it's not an extraneous solution by double checking that in the original, the domain would be that x can be any real number such that x does not equal 0, because in particular you want to make sure that the denominator does not equal 0, and that when you plug in 1/2 in particular into that expression, at no point am I dividing by 0, so I am okay. Not dividing by 0 in any way, shape, or form. Let's go ahead and check out another example. So in this next example, the least common denominator would be x plus 5 times x plus 2. So I'm going to multiply both sides by x plus 5 times x plus 2, x plus 5 times x plus 2. And then you're going to notice that, okay, x plus 2 divided by x plus 2 makes 1. I'm left with negative 4 times x plus 5. X plus 5 times x plus 5 makes 1. I'm left with negative 5 times x plus 2. And then I'm going to want to simplify further. So I can distribute multiplying by negative 5 by both of these terms. So I get negative 5x minus 10 in particular. And then I'm going to go ahead and distribute the other side as well, so that would be negative 4x minus 20. Now I want to move all x's to one side, all constants to the other, so in particular I'm just going to choose to add 4x to both sides, so then I get negative x minus 10 is equal to 20. Then I want to add 10 to both sides, so I get negative x is equal to positive 30. Divide by negative 1, divide by negative 1. I'm going to get x is equal to negative 30 as my final solution. But I actually made a small mistake. I would actually encourage you to pause the video and find my mistake. That's a good skill to develop. In particular, this negative 20 I magically turned into a positive 20, so I'm really doing negative 20 plus 10, which would get me negative 10, and then negative 10 divided by negative 1 is going to get me positive 10. So it's always worth double checking over your math there, because it's very easy to make a small mistake like that. Now I need to check with the original domain. So in the first fraction, we want to make sure x plus 5 cannot be 0, so x cannot be negative 5. In the second fraction, x plus 2 cannot be 0, so x cannot be negative 2. And our solution of x equals 10 is neither of those, so we are okay. So let's check out this next one. Now before we jump into this next one, it's probably going to be best to go ahead and factor that original denominator. So we have 6 over x times x squared divided by x is x, 2x divided by x is 2. So that will actually allow us to recognize that least common denominator is x times x plus 2. This is also a good example where before you might have been wondering, why didn't you just cross multiply? I could have cross multiplied if that's something you're comfortable with. However, cross multiplication is not a method that works here, because I've got two different terms on the left hand side rather than just term equals term. So this is a more versatile approach. So let's go ahead and solve this. So we want to multiply everybody by that least common denominator. Apologies if you can hear my dryer going off in the background as well. So if we multiply both of these by the least common denominator, x divided by x is 1, x plus 2 divided by x plus 2 is 1. So I wind up with 6 here on the right-hand side. X divided by x is 1. I still have x plus 2. Technically, I'm distributing the 1 to both terms, but multiplying by 1 doesn't do anything. X plus 2 divided by x plus 2 is also 1, so then I just have an x. Now I'm going to combine like terms. X plus x is 2x. Then I want to move all constants to one side, so subtract 2. And then I need to divide by 2, so then I get x equals positive 2 as my final solution. Now I want to also note that here for the domain, you make sure x does not equal 0, thanks to the first fraction. You make sure x plus 2 does not equal 0, which means x cannot equal negative 2 for the second fraction. And the third fraction is just going to repeat that domain in particular because you have an x times an x plus 2. So getting positive 2 at the end was actually not an issue because it's not the same thing as negative 2. So we are good. So I'm going to encourage you to go ahead and pause your video and try these next two on your own. Okay, let's go ahead and talk about these. So for this first one, the least common denominator would just be x minus 1 because that 3 is actually over x minus 1. So I'm going to take every single term and multiply them by x minus 1. X minus 1 divided by x minus 1 is going to make 1. And I'll be left with 4 plus 3 in parentheses, x minus 1 is equal to 5x. Then I'm going to want to distribute, so I get 3x minus 3, drop down the 4. Then I want to combine like terms within one side, which would be 4 minus 3 gets us 1. Then I want to move all x's to one side, which gets us 1 is 2x. Then I want to divide both sides by 2, so I end up with x is equal to a half. In terms of the original domain, I needed to make sure that x minus 1 could not be 0, so x could not equal positive 1, so having x equal 1/2 is actually okay, still within the domain. For this next one, its least common denominator looks like it's going to be 2 times x plus 1 times, and then actually before I start also doing that, we actually notice that this is factorable, and I think I might save myself a little bit of time if I factor that, because in particular, 3x plus 3 have a greatest common factor of 3. 3x divided by 3 leaves us with x. 3 divided by 3 leaves us with 1. And this is what we are left with. So actually we don't need the x plus 1 there, but we do need to toss on this 3. So instead of just a 2 out front, that would be 2 times 3 as part of that least common denominator, aka 6. So I'm going to multiply both times by 6 times x plus 1. Then I want to note what's going to cancel and make 1. X plus 1 divided by x plus 1 is going to make 1. 6 times 6 will give us 36. 6 times 3 divided by 2. 6 times 3 is 18. Divided by 2 will leave us with 9. Or you could also sort of equivalently think that those 2's would cancel and we'd be left with a 3. And then we still have times the x plus 1. And then for this last one, the x plus 1 divided by x plus 1 is going to cancel and make 1. And the 6 divided by 3 is going to simplify to 2. Still times that 8 to make 16 as your final total answer. Or alternatively, you could have done 8 times 6 divided by 3 and also gotten 16. Now we want to keep on simplifying. So in particular, negative 9 times x gets us negative 9x. Negative 9 times 1 gets us a negative 9. Drop down to 36. 36 minus 9 is going to get us 27. Minus 9x equals 16. Keep on going. We want to subtract 27 from both sides, so we're going to get negative 9x is equal to, and I am blanking on 27 minus 16, that would be 21. And as a final step, we're going to divide both sides by negative 9. 21 over negative 9 does simplify a little bit. In particular, 3 goes into both, so we'd end up with 7 over negative 3 as our final answer. Now, technically, according to the domain of the original, we're going to have to make sure that x does not equal negative 1, since we need to make sure that x plus 1 does not equal 0. But in this case, x did not equal negative 1, so we are indeed good. But I made a small error again. What was that small error that I made? When I did 16 minus 27, I should have noticed that that was a negative, and a negative divided by negative is a positive. So that final answer would actually be positive. So always take a moment to sort of recheck over your work like that to notice that if you made a small sign error in that fashion. This last one is going to be pretty similar, so we need to again make sure that we're noting the least common denominator. In this case, the least common denominator would be m plus 7 times m minus 7. If we take every single term times m plus 7 times m minus 7 times m plus 7, m minus 7. How do we know that? Well, because this denominator actually factors into m plus 7, m minus 7. So we didn't have to repeat that. And then we want to note what's going to cancel. So in particular, in the first one, the whole denominator cancels with the whole least common denominator, and you're just left with 5m. For the second one, the m plus 7's cancel, and you're still going to be left with plus 8 times m minus 7. Second one, the third one, m minus 7's canceled, and you're going to be left with m plus 7. Then you want to make sure to distribute 8m minus 56, drop down the 5m plus. 5m plus 8m is 13m. Then we want to move all m's to one side, all numbers to the other. So you're going to end up with 12m is equal to 56 plus 7 gets you 63. And then you need to divide by 12. That fraction will simplify a little bit. In particular, 3 is going to go into both numbers. Actually, 6 goes into... No, 6 does not go into both numbers, just 3. So 63 divided by 3, well, 60 divided by 3 would be 20, so 63 divided by 3 will be 21. 21 divided by 3 is 4. And that is our nice, beautiful final answer. For this last one, you again want to factor that left-hand side a little bit further, in that 2x minus 4 will factor into 2 times x minus 2. And then we can notice that that means that the least common denominator would be 2 times x minus 2. So we want to multiply all of our terms by 2 times x minus 2, times 2 times x minus 2, times 2 times x minus 2. Cancels, 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 cancels. So we're left with x minus 10 times x minus 2 is equal to 2. Then we're going to want to go ahead and distribute. Negative 10 times x gets us negative 10x. Negative 10 times negative 2 is going to get you positive 20. Go ahead and drop down the x, drop down the 2. X minus 10x is going to get you negative 9x. Then you can subtract 20 from both sides. You're going to get negative 9x is equal to negative 18. Divide by negative 9, divide by negative 9. And then you'll get x is positive 2. And really, actually, in the first one, we really should have also made note of the domain. In particular, you want to make sure neither of those equals 0. So it's the case that m cannot be 7 or negative 7. We were good. That was not the case here. However, in this next one, might be the case. Because in this next one for here, we need to make sure that the denominator never equals 0. So in particular, x cannot be 2. And lo and behold, that's actually what we got here. So this is considered what's called an extraneous solution. If I actually plugged him back in, I would end up with 0 in the denominator. So this solution does not exist for that reason. So always be sure to double check that.